everybody, it's Stephen Feuerstein, back from my summer break. It was a nice summer break, kind of hot, managed to remove a lot of invasives, but we're back on Feuertips, and I have a special guest with me who I'll bring on after a couple minutes of ranting. Chance to see my dog. There's Falcor, the lap dog, the super lap dog. So yes, it's been over a month, I think, since I saw you last. Lots has happened. Let's see. A third of Pakistan is underwater. My condolences to the citizens of the United Kingdom on their new prime minister and their upcoming enormously awful energy crisis. The war continues in Ukraine. On some good notes, there's a possibility that our former president may well be in serious legal jeopardy due to his own actions, of course. And to escape all of that, we have software. Now, this session is going to be fun, not only because you get to listen to somebody else with some real world experience who's actually been developing applications for a number of years now, as opposed to me, but also it was really fun for me because it turns out that a training I did in Poland, in Warsaw, many years ago, really inspired her to take some new turns and directions in the way that she writes her applications, and is now coming back to kind of report on what she learned from me and how she's applied it, with a lot of interesting advances beyond anything I said. But I thought first that I might share my screen for a moment. Mark, thank you. And I used to have so much fun in my presentations, and it reminded me when she told me about where her presentation came from. So this is close to the kind of materials that I used to do. Come on, there we go. So I used to do a talk where I offered magic tricks, and I would show you that with nothing more than the power of logic and smart software, I'll convince you that testing is fun and SQL is bad, 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 bad. And she's actually going to talk about SQL is bad, though we do all love SQL. But it was really fun to revisit some of my slides. Like, for example, this is one of my favorite ones. Can we really call what we do work? I mean, we sit around, think about stuff, write it down with our fingers, and we get paid usually a pretty good amount of money, good benefits, etc. And meanwhile, there are all those people out there doing real work. We saw this during the pandemic, especially, keeping our lives together. So my gratitude and thanks to all the people with real jobs who really have to work for a living. And now please stop sharing my screen. And let's bring on Monika Lewandowska. Monika,
Hi.
welcome.
Hi.
So Monika's here to talk about the European energy crisis they're facing this fall. No, all right. I did all that stuff already. So now what we're going to do is talk about software. And as a reminder, one of the wonderful things about software in this age of crises is that we get to kind of move away from the messy real world and live in the cyber world where we create all the rules, we write all the code, which means we can make it so lovely and beautiful and bug-free and fully tested, and usually not. But Monika, I think, has some really good ideas about how we can organize the code as we write it, or even after we write it, to make our code easier to maintain, more performant, more secure. Monika, what have you got for us?
Thank you for these kind words. And again, my name is Monika Lewandowska. I'm Oracle designer and developer since the last century. So please do me a favor and do not count how long ago it was. As you mentioned, 2007, it was this training where we met. I was a student on your training in Poland, and yes, I left this training shocked because for the first time I've heard from you that SQL is bad. It's stuck in my head.
Be a shocking thing to say. It's true.
Yes, it's shocking, and it's stuck in my mind, and I couldn't stop thinking about this. And when I went back to home, not home, work, I started noticing a lot of weird things. First, SQL are everywhere, everywhere. There are hundreds and hundreds of SQLs everywhere. And what was very interesting, many of them are similar or even the same. And if not similar, they're retrieving data from same tables, because we work on one system. So we have 10, 20, maybe 100 tables, but we use usually 5, 10 from them the most. So why? It is mainly because it's so easy to mix PLSQL and SQL that it is even, maybe it's too easy. Because you write a PLSQL code and then you say, oh, I need some data. So what you do? You write SQL. You write PL/SQL code later, and now you think, oh, I need some more data. So you do SQL. Don't worry, yeah, it's fine. And you do your code and your system without noticing that the number of SQL is rising and rising and rising. So it's very bad, very, very bad. And what is more, I ran some traces on our system, and it turned out that if in the code I have maybe tens, hundreds of SQL statements. When I run trace, it's around that we had millions SQL executions.
Mm-hmm.
It was terrifying and terrifying, sorry, horror. And what was funny thing, the SQL that has had the biggest number of SQL execution in that system was select system from dual. It was, I don't know how big number it was, but it was, I don't know, 5 centimeters long number. So it was really, really big number of select system from dual. So what if SQL is really actually bad for our system? Imagine, what is the slowest part of our systems? If you tune something, if you optimize something, it's usually SQL query, mm-hmm. Yes? Where we have the most errors? In data or SQL? Mm-hmm. Why changing the structure is so difficult? If you want to change structure, you do alters the table or something like this. It's not very complicated. So why it is difficult? It's difficult because SQL reflects the structure of our system. So if you add the column, you had to change all your SQLs. So it's time consuming and difficult. And why writing the unit test is difficult? Because we have SQL and we have to load data, configure the system. This is the problem. So long story short, without SQL, our systems can be fast, efficient, deterministic, easy to maintain, easy to understand, easy to fix, and error-free. So,
all right, but wait. I have to pause us for a moment, because when I said SQL is bad, I didn't really mean it in the sense that hopefully you actually do like SQL, right? SQL is a great language. In terms of the SQL is bad, for everybody else out there, the argument I was making is that I'm going to prove to you that SQL is bad. So I would start by saying hard coding is bad, right? If you hard code the same value in multiple places, we all agree hard coding is bad. And then I went on to say SQL is the worst form of hard coding because it's directly related to the application as a whole and its data structure. And those are the things that are always changing. If you have the same SQL in more than one place, you're hard coding the current state of your data structures, et cetera, et cetera. Therefore, right, if hard coding is bad and SQL is hard coding, then SQL is bad. But I just want to point out to everybody, neither of us are saying you shouldn't write SQL. It's going to be in your application. The question is where and how, right?
Yes, exactly.
Okay.
Because yes, we cannot get rid of all SQLs because we work with data. We need data. So if we need data, we need SQL. So, well, let me show you something. Can you share my screen?
Did you click on the share button below?
No.
You have to give it to us so then we can share it.
Okay, yeah. Okay, what I have here, it's HR schema and, employee terms. I bet most of you know this schema. And what I want to do is to give a rise for employees. So I created some column with configuration parameters that I want. For example, for president, I will give 45% pay rise, finance 10%, and so on and so on. So I have in employee table, EMP table, it's a copy of employees. How much? 1,000 rows. And I have a procedure to calculate this pay rise. Very easy one. This is the loop for departments, because I don't want to get pay rise for 10th department. Then I have a loop for employees, because I need some data from employee table. And then I have a procedure to calculate pay rise. It's very easy, just some more queries, because I need data from employees, and some query to jobs table, because I need configuration, calc new salary, and update. So it's as easy at this, and I'll run it. Moment. So even if we have so simple procedure, we have 3,000 SQL execution and 1,000 updates. Yes. So what if we add some more data? For example, we had 1,000 data rows. Now we will have a little bit more. Let's see. 5,000. Good. And run. Okay, now we have, instead of 3,000 of SQL execution, 15,000 of SQL executions, and time rose from 1 second to almost 4 seconds. So this is the number of SQL execution grew rapidly, very dramatically. And this is only very short, very simple procedure. What if we add another procedure here? For example, I want calc, I don't know, Christmas bonus. Yes, similar procedure with, I need some data, I need some configuration, calc bonus, and update. So let's see how it could look like if we run it. A moment.
Oh no, it's an infinite loop. Wait a minute, that's when it's my presentation. Then it's an infinite loop.
No. So now instead of 15,000 SQL executions, we now have 26,000 SQL executions, and processing time is almost 10 seconds. I show you something more. I have new version of those procedures, and a little bit more waiting. I hope the result will surprise you. Okay, so now we have old version procedure, 15,000 SQL execution, 5,000 updates, almost 4 seconds processing time, and new version of this procedure doing same thing.
Really?
Same thing. 2 SQL executions, 1 update, almost 0 processing time. And
so you ran it on a bigger computer? Is that what you did?
I have only an old laptop, but hey. And this is a version with 2 processes. So calc salary, new salary, and Christmas bonus. And we had with old version 26,000 SQL executions and almost 9 seconds processing time. With new one version, 2 SQL execution, 1 update, still nothing changed, and almost same processing time. I could do more examples, add another rows and records and run it. And now second version would be still the same. One SQL execution, two SQL executions, one update, and 25 milliseconds of processing time. So how can I, how I could get rid of those SQL executions? What I've done? How I reduce it? Are you? Do you want to know?
That's quite a dramatic difference.
Yes, it is. Yes, it is. Really. So yeah, SQL is bad. But if limited amounts, it's good. So when I started to think about this, how to create or design, organize my code, I had two questions. What is faster, full scan or index scan? It was interesting because in my system, on what I was working then, almost all queries were using index. So almost all were indexed, fast, tuned, whatever you want. But the system as a whole was slow, very slow. And once I noticed that during the processing, it was night processing, some batch processes, and so on, I process almost all my data. So basically, if you need to retrieve all your data from table, full scan is much faster. Yes? Is it right?
Interesting.
Yeah. And after answering the first question, I started to wonder how many SQL queries I need to accomplish the process. If in first point I retrieve all my data, so why would I retrieve them again? I have it, yes? So it was starting point of my idea of my I don't know, it's mine.
Sure.
It's this idea how to organize the code. What we did is I prepared some processing scheme how I want to do how I want to design the processing. So first, before I start all processes, I had SQL for retrieve all my configurations. One SQL for configuration, and every configuration are loaded to collections. So as many collections as configurations. Second step was to get my main data. So I don't know if it's banking system, accounts, cards, etc., clients, products, everything we need to process to close the end of the day or so what we have in system. And again, it was only one SQL to retrieve all the data. And you may think that this SQL is very complex, long, and so on, but not. It was 20 lines of code because I joined here about 5-6 tables where conditions were very simple because just joins conditions and some additional conditions like client is active or some dates to limit the data. So the query was very simple because I wanted to retrieve all data without any calculation, manipulation, raw data for another processes. I loaded to the global collections again, using bulk collect and of course limit because I worried about the memory. And then I started the processes 1 to 20. What was important, no SQL was allowed here. Pure PLSQL. If I needed something, I had to use global collection or pass information or parameterization through parameters in or out. If I wanted to change some data, I do that using parameters in out and copy, no copy option. So it was in those processes, I had pure PLSQL code. No, not even one SQL there.
That's really something, yeah. Now, and I just point out, I'm sure you would agree, this is not something you can do with every process that you've got, but in terms of this specifically, certainly a batch processing approach, this kind of segregation can make a lot of sense and have enormous impact.
And the last step was to save data, so DML using, of course, for all. So yes, so maybe I show you the difference in real code, not real, this example, how I did it here. So instead of this loop, I have bulk collect to retrieve all the data. Instead of this loop for EMP table, I have loop for collection through collection.
Building up the collection, filling up the collection.
Yes, filling up the collections, and then instead of those nasty SQLs to get configuration, I just run this get jobs function, which looks like that. I just load all records from jobs table using loop because I want to have index.
I was going to say, why aren't you using bulk collect?
Because I want to have index as a job ID, because it would be easier to retrieve, to get the configuration from the collection for specific job ID. And if I have this configuration, I return the right one. And then those procedures, rise salary, for example, I pass as a row type every information for employee ID, for employee row as a row type, and I pass to the procedure my parameterization. So this is rise PCT percentage, and just calc new salary. Look at first glance how easy it would be to test it. You don't need any SQL, any data, any configuration to test it, and rise salary and calc price bonus are the most error-prone parts of the system, this system, because we have there some calculation, manipulation, and so on. So we should focus on those procedures to check them, to verify if they are valid and correct. So without SQL, without data, if we pass everything through as a parameters, or we have some global collection, etc., preparing unit tests is very, very easy. So this is how I created this. I changed and refactored this procedure, and I bet many of you ask or say now that it's so easy. It's just two procedures. I know how 100 lines of code. So for something simple, it's very easy to get this approach and create procedure with this scheme. But I want to show you something more. That are some metrics about the system where I introduced this approach.
So these are real. Now you're going to give us
real information, real metrics, real system where I had really one SQL to retrieve data, main data, so clients, and about 20 queries to retrieve configuration, because we had about 20 tables for configurations. So for whole system like that, I will show you in a moment, I had 21 SQL executions. Okay, so we had 100,000 lines of code, 100 tables approximately, 100 packages, 3 million clients in this database, 5 million products, and I call it main data. So clients plus products, it's my main data. We had 1 million events per day. Every day, 1 million new records. For example, if we have a system, mobile phones or so events would be phone messages, etc. So I call it like events. During a night, we had 20 processes, separated processes like calc fees, calc interest, etc. And processing time, original processing time was 10 hours, sometimes 13, sometimes 15 hours. And we reduced this time to, somebody want to guess?
1 hour? Half an hour? 10 minutes? 15 minutes?
Yes.
Sweet.
And before we started this project, this refactoring re-engineering project, I estimated the 15 minutes time, that this is my goal. And
really?
and we reached it. And how I estimated this time, I assumed that the most slow part of the system is retrieving data and saving data. So I prepared a procedure just to get my data using one big SQL, just a loop with random changes and saving everything using for all. And I measured the time. It was about 10 minutes. I added 5 minutes just in case.
For everything else.
It turned out that, yeah, I was right. And
very nice.
Product, yeah, we reached those 15 minutes. So yes,
perfect.
I think, what I want you to remember is that we can reach this, we can do this if we will treat the SQL as a data layer. You know, we have about 3 layers applications. So I always thought about a database that I can do this in Oracle. So I separate SQL from business logic as much as possible. So I get every data before I start functional and business procedures. And after the last process, I saved everything. So, one thing at the end, I would like if you go back to home to work, you do some trace, you run some trace and check how many SQL execution you have in your system. It could be really, really shocking.
Yes.
So, yeah, so thank you.
Thanks. So, yeah, let's wrap up a little bit, and then you're going to tell us about one of your favorite books, and we'll see if we've got any comments we want to take from the audience. So my takeaway from that, Monika, is you took some ideas I offered up around SQL. Basically, what I was telling people is that if you're concerned about hard coding, SQL is a very extreme form of hard coding. So be very careful about where and when and how you write it. Follow the single point of definition approach. It should just be written once and used then from that one location. You took it, I think, a step further, now linking that up with deterministic code that I had talked about weeks ago on Feuertips, which is to say, if I can segregate out all the non-SQL logic and make that a separate body of code, that will be easier to test. I don't need to set up the database and the tables. I can run it off of my collections, for example. And it worked really well in that environment. And as I mentioned earlier, and I'm sure you'd agree, that worked really well for this kind of batch process. When you're talking about transactional code, we're not talking about one big job that ran for 10 hours. So the chance that you're going to be able to refactor other models of applications along the exact same lines is probably low, but that doesn't matter. What matters is that core principle, right? We want to do everything we can to avoid copying and pasting SQL. And there are lots of techniques for doing that. The most important one is really having a good, strong concept of how you want to design your code and put it all together. Let's see if we've got some questions here. So I'm a little bit confused about memory management from Anton. How do you pull all of this data into memory and save all of it at once? Is it all in memory?
Yes, this is the bulk collect mechanism. So it is done by Oracle.
So Anton, I think this is another example of where this technique really makes sense for a batch process. So I think what Anton is reminding us is that when you fill up a collection, you're filling up PGA memory, process global area memory. And if you have a lot of people running, so if we had that same process, let's say it used 10 megabytes of memory, we have 100 people doing it. That's 10 times 100, that's 1,000, that's a gigabyte. So one of the things you have to watch out when you do this kind of transferal from SQL into collections, especially collections, is that you could run out of PGA memory for your organization or for an individual session. So the idea here is that I'm running a single batch process. The DBAs know we're going to use a lot of memory. They've configured it for this, so we're good. But it's definitely something to watch out for. And from Judith, were those calculations really so row specific that you needed PL SQL to process each row instead of doing a single update? Well, that's where you ended up with, right? Was a single update? You did a for all update at the end.
Yes, this is at the end we have update using for all. So we update everything, we process error, yes.
And I think, can you put up grams? Why not just do this in SQL? We'd have to take a closer look at this. So remember what Monika showed you was a simplified version of what she built in her production code, which of course would be way more complex. It's quite and when I was looking at her initial set of code, I'm thinking, well, why would you write it that way? Select and select and select. Really what I would say Monika was modeling effectively is how many of us write our programs. I've looked at a lot of code and it's like, seriously, you did what? Why? What? So probably there's a good chance that could have been simplified even, and maybe even just SQL. But that would just be looking at your simple example and reducing that to a more simple example, which is not the point of the example. And Claudio, if it is a process, think like ETL using a cursor in collections. Yeah, that's right. It did map to that really nicely. So obviously, whenever any of us do demos, it's always simplifying the situation to get the point across. The point being, basically ask yourself before you write any SQL, do I need to write this? Have I done it before? Should I encapsulate it? And Nils, I'm not sure if you're still on. Can you put the comment back up? I wasn't sure. I know what I think he meant. You had like I old one because I for integer. Is that right? In your naming convention, do you use the first letter of your names to indicate the data type? I think that's what Nils was referring to.
This one?
And you have to share it again. But okay. Oh. So is that right? If it was a number, it would have started with N?
Yes. I like this because it makes my life easier when I know what data type the variable is, and I like to know when I'm in the code.
So at any point in your code, if you glance at it, you'll say, oh, right, that's a number. Oh, that's a date. Interesting. Yes. I've never done that. Maybe I'll give it a try.
I know.
Huh. Okay, great. So cool. So I think that covers our questions. We are pretty far along in time. So Monika, one of our special features is I share one of my favorite cultural artifacts. I started out with books, but I have a lot of favorite books, but I branched out to other things. What have you got to show us as a favorite cultural artifact that has had a big influence in your life?
I'm not sure if it's the biggest influence in my life, but this is the book I've read recently. It's a definite book of body language. And it was very interesting because it's not only about to recognize if somebody is lying or not, but also how we as a men and women differ, how we differently see each other, or, for example, how to create friendly environment in your house, home, or office. So it's a very thick book and really, really interesting. So I invite you to buy it and read. It's a little bit open mind.
So the link's in chat, the definitive book of body language. I'm going to check it out. Yes, the sort of thing we take for granted. We don't even realize we're experiencing or reacting to.
In this book is the answer for the question, why men are still losing their keys and couldn't find it.
Why men are still losing their
keys.
Keys. Oh, interesting. All right, I got to check that out.
And women are able to find it right after they get out of their room. The answer is in the book.
All right. So thank you so much for coming on. And great, if you have a blog about your tips. Oh, right. So I'll talk to Monika about following up, and I'll put together a blog post that goes with the video on the Feuertips page. It may link to her blog post, or we'll just incorporate her comments. Final note: we we take $25 from the InSum bank account and we donate it for a worthy cause. We started out by focusing more on healing the planet, the non-human part of the planet. With the invasion of the Ukraine, we kind of switched gears a little bit, and I kind of unilaterally decided this week we're going to donate to the effort to support Pakistan as it rebuilds, recovers from really terrifying weather conditions, which are probably going to be plaguing us for the rest of our lives. On that extremely positive note, I wish you all a great return to work in the fall, and I'll see you in a couple of weeks with some more Feuer tips. Again, thank you, Monika. That was great. Much appreciated.
Thank you.
All right. Take care.
Thank you, and bye.
Bye.